Hello students, and welcome to this video where we're going to talk about rates of change related to velocity and marginals. So far what we have talked about, we have looked at slope and we've talked about rate of change, and now we're basically want to take these two topics and we want to relate them to real world applications. So we're going to look at things such as velocity, acceleration, think about population growth, and even look at unemployment rates. So there are two types of rate of change. So there's two types. I'm going to call this ROC, rate of change, and there's two types. We have average rate of change. So that's one type that we're going to consider. And then the other kind is instantaneous rate of change. So instantaneous rate of change. So when I use the average rate of change, this is my typical idea of what slope is. And remember that slope is measuring the rate of change. So you know the definition as like y2 minus y1 over x2 minus x1. And now, because we're thinking about application problems, we actually have specific points. So maybe our A and B. And so we're still looking at the differences, the changes in y's versus the changes in x's. Note that this is using the secant line, and the secant line uses 2 points as we learned in one of our previous videos. Well, instantaneous rate of change is going to use our tangent line. Because we're using our tangent line, we only have 1 point, and therefore we're going to use our limit definition, which is the limit as x approaches 0 of our difference quotient, which is x plus delta x minus f of x all over delta x, because we only have that one specific point. So in this idea with instantaneous, if y was your distance and x is your time, then the rate of change would represent a velocity because your measurements are distance and time. Okay, so just to give you an example. So I want to solve a problem where we kind of look at average rate of change versus instantaneous rate of change. So we're going to choose a function. We're going to say that our function is equal to x squared minus 3. And I want to find the average rate of change over the interval 0 to 2. So I'm finding the average rate of change over the interval of 0 to 2. So that means I'm going to need to figure out what does f of 2 equal so that I can subtract it from f of 0. So those are my respective y values. And then over my difference in my x values. And if I actually plug in 2 squared is 4, 4 minus 3 is 1, minus, and now plug in 0, 0 squared is 0, minus 3 is a negative 3, and 2 minus 0 is 2, and if I simplify, I get 4 divided by 2, which is just equal to 2. Okay, so this is saying that the average rate of change of y is 2 units per the increase in my x. Okay, so I've done my average rate of change here in pink, and in purple I'm going to come down here and I'm going to do the same problem with instantaneous rate of change, but I'm going to want to look at a point, and I'm going to look at the point x equals negative 1. So when I think about instantaneous rate of change, because I'm using my limit definition, we know that this is just telling us to find our derivative. So I need to find what is my f prime. So if I know that my f function is equal to x squared plus 3, I can use my power rule, and I end up getting that f prime is equal to 2x. So remember, this is representing the equation, and if I want to find my instantaneous at the point x equals negative 1, I'm going to actually plug in negative 1, and I get the value negative 2. Okay? Alrighty. So you see the difference between average rate of change versus instantaneous rate of change. I do want to add, I'm not providing a whole lot of examples, but I do want to talk about rate of changes in economics. There's some key words that are included in this section that we'll be utilizing in class more, and so I just want to make sure that you've seen them. We refer to this as our marginals. So the three that we're going to talk about, we're going to label as P, R, and C. P is going to stand as our total profit. Our R value is going to stand for our total revenue. And then our C value is going to stand for our total cost. And we've actually looked at these before when we were looking at our systems of equations and thinking about cost equations and our revenue equations and profit equations. So now we want to think about the derivative. So if I'm going to find the derivative of my P equation, that is going to be my marginal profit. So that word marginal represents that you've found the derivative. If I want to find the derivative of the R function, that's going to represent my marginal revenue. And if I want to look at my cost derivative, so I'm doing dc over dx, that would represent my marginal cost. And a great representation of this is in your book. We're looking at page 109. Word problem number 5 is a great example of how we can utilize rate of change in economics. But again, I hope this gave you a good, quick, brief idea of the difference. Again, quick overview. We're talking rate of change. 2 types. We got average and instantaneous. Average is kind of the old school method that you're used to, where you use the secant line. So you're looking at 2 points using slope. Instantaneous rate of change is our new type of rate of change that we can look at. We're using the tangent line, so only 1 point. So we're using the definition of derivative, or you can call it the definition of the slope. Hope this video was helpful. As always, if you have any questions or concerns, please don't hesitate to reach out.